Hello everyone, welcome back to our channel. Thank you for following up on us. Thank you for the subscription. Thank you for clicking on the notification button. Thank you for liking our videos. Thank you for sharing our videos. We are happy. Thank you for promoting us. God bless you. So we are having this question to be answered. And it said if sine square theta plus sine to the power of 4 theta plus sine to the power of 6 theta plus to infinity is a solution to a quadratic equation that says s raised to power 2 minus s minus 6 equals to 0. And we are asked to find the values of theta as theta lies between 0 and 360. That the values lie between 0 and 360. And we say solution. So if you look at this carefully, you realize that it's a geometric progression to infinity. It's a geometric series, and with a common ratio of sine square theta. If this is true, we would therefore say that the geometric progression, the sum of geometric progression to infinity is given as s equal to a all over 1 minus r. And r is the common ratio. The a is the first term. Coincidentally, is the same thing, sine square theta. And the sine of angle is usually less than 1. That is to say, the ratio is equal to sine square theta is less than 1. So if we continue with this to put our values here, sum to infinity will be sine square theta all over 1 minus sine square theta. But from our trigonometric identity, we have 1 to be equal to sine square theta plus cos square theta. And if we do this very well, we have cos theta, cos square theta to be 1 minus sine square theta. You see this? So in the place of 1 minus sine square theta, we are going to replace it with cos square theta, which is the denominator. So this very well becomes equal to sine square theta all over cos square theta. Yes. And the sum to infinity eventually becomes tan square theta, since sine theta, sine square theta over cos square theta is equal to tan square theta. And this is the solution to the geometric progression. And from our equation, it is said that this is the solution to the quadratic equation. And so our responsibility is to solve the quadratic equation and equate the two solutions for s to tan square theta, like so. So let's come over here. I'm going to say s squared minus s minus 6 equal to 0. So the factors for here will be minus 3 and plus 2. Yeah. Minus 3 times plus 2, we have minus 6. Minus 3 plus 2, we have minus 1. So we're going to place our factors there. So s squared minus 3s plus 2s minus 6 equal to 0. Our good. So here we're going to put them in brackets and read them. So what is common here is s, yeah, obviously, s minus 3 plus, we have 2 here, we have s minus 3, yeah, this is correct. Since the bracket is the same, we're going to write it once, which is s minus 3, and this s plus 2 equal to 0. Here we can have s to be equal to 3 and minus 2. So these are the solutions from the quadratic equation, but from our initial equation, we are asked that this expression, the geometric series, is a solution to this. And now we are having solution to the quadratic equation. So our task is to equate the tan square as a solution to the geometric series to each of the solution we have from the quadratic equation. What do I mean? I'm going to say going forward that tan square theta is equal to 3, or tan square theta is equal to minus 2, is what I'm saying. So we're going to continue solving it from the other side. So we have tan square theta equals 3. This is the first part. Let's deal with this first. Later we'll do the second one. So it becomes, if we take the square root of both sides, tan theta will be square root of course, plus or minus square root of 3. You know, and theta will be arctan plus or minus square root of 3. And if you do this very well, you're going to have theta to be 60 degrees. And since we are asked to find the values, plural, values of theta, of course this is the value of theta. But we're going to remember our quadrant. We use a slogan, all silly Tom car, all silly Tom cars, meaning sine, cos, and tan are all positive in the first quadrant, all. But only sine is positive in the second quadrant. That is to say, cos and tan of any angle are negative in the second quadrant. So on the third quadrant, only tan is positive. Also means that sine and cos are both negative of any angle, are both negative on the third quadrant. And cos, of course, the fourth quadrant, only cos is positive, sine is negative, tan is also negative. So if we go by this, since we are asked to find the values of theta, now we have theta to be 60. The first value of theta is obviously 60 because it falls within the first quadrant from 0 to 90. Yeah. So for the second value of theta as a positive angle will be, it will fall within the third quadrant. And in the third quadrant, if you are moving this way, this is 180 plus 60 to be somewhere around here. If this place is 60, that is 180 plus 60. Theta therefore then will be 180 plus 60 degrees, which eventually, this is degrees, which is eventually 240 degrees. This is the second value of theta. And now we're going to consider when theta is negative. Yeah. So what is tan? Tan falls in the second and fourth quadrant. Tan is negative in the second and fourth quadrant. So if I'm moving from here to here, this is 90, and up to here is 180. So what would theta be? Theta would be 180 minus 60. Yeah. Theta in the third quadrant for the negative value will be 180 minus 60, which is equal to 120 degrees. 120 degrees. And of course, for the fourth quadrant, for the last place, we are having theta moving from here up to here. This is 270 plus here will be 360. So if we take away theta minus is negative, the fourth quadrant will be theta equals to 360 degrees minus 60 degrees. Of course, this is 300 degrees. And the value of theta that we have obtained will therefore fall within theta will be, the first value is 60 degrees and the second value is 120 degrees in ascending order, and the fourth value will be 240 degrees, and of course 300 degrees. Now we are done with tan square theta equals to 3. So let's come to tan square theta equal to minus 2. So tan square theta equals to minus 2. So if you want to take the square root of both sides to remove this square, tan theta will be plus or minus square root of minus 2. And this is where we are having a bit of challenge. Square root of a negative number does not exist. So it leads us to a complex situation. So the values of theta that we have obtained previously will end up being our real values for thetas. And this is our answer. Thank you for staying tuned. So if you watch the video to this extent, peradventure you gain some values, please click on the notification button. If you have not subscribed, please subscribe to our channel.